Hello everyone and welcome to this video. In this video, we're going to talk about Unit 7, multiplicative reasoning. First, we're going to start with 7.1, direct proportion. We need to understand the meaning of direct proportion. Now, we understand from a graph that direct proportion is a straight line that starts from the origin point. So this means that this is a straight line that doesn't start from the origin point. It means it's not a direct proportion. So this one is not direct proportion. Same idea here. This is a curved line, so it's not a direct proportion. And for these two graphs here, we have a straight line that starts from the origin point, so it is a direct proportion. Same idea here. It is a direct proportion because it's a straight line that starts from the origin point. Now, the meaning of direct proportion, it means two values that increases together and decreases together. So let's say a value on the y-axis here and one of the on the x-axis. So these values, when the x-axis value increases, the one on the y-axis will increase with it. That's the meaning of direct proportion. So let's take a look at some questions here. Question two here. Now we're going to talk about how we solve problems related to direct proportion. Let's cover this so we can have space. I'm going to answer some of the questions and the ones that are the same, we don't have to do them, okay? First, question two. The price of eggs varies in direct proportion to the number sold. The price of 6 eggs is $1.98. How much will 12 eggs cost and 15 eggs cost? So basically, when you have a question like this that talks about direct proportion, and as we said, they might tell you it is direct proportion or they might not, but from the question you will know. If the question is not talking about time, and the time consumed to do something, it means it is direct proportion. Or they might mention in the question that it is direct proportion. So how do you answer questions like this? First, you take the ratio that they gave you, which is this one. 6 eggs are bought or they cost $1.98. First, you write this proportion here or ratio. So we have eggs, we write eggs, or we write E for eggs like this, okay? And we write 6 under it. And then here we write money or cost. We can do money, we can do cost. And then $1.98. So 1.98. And this is the first step. So first thing you do, you take the ratio that they gave you in the question and you write it as a first part, okay? Basically, I like to put them in boxes like this. So I put a box here and a box here. And these are in front of each other. It means 6 eggs will cost $1.98. Okay, $1.98. Now, the question here wants us to find the cost of 12 eggs. It means I have to put them under the eggs here. So I'll put 12 here under the eggs, put it inside a box like this. And I want to find the money. It means I will leave it empty. Now, I put an X between these boxes like this in the middle. I put an X. Now I take the ones connected with a line and multiply them by each other. So the two boxes connected with a line are these boxes. These two boxes are connected with a line. So I have to multiply them by each other. And then divide the answer by the box that I didn't use. So I'm going to take 1.98, 1.98 like this, and multiply it by 12. Multiply it by 12 like this. So 1.98 times 12. And then take the answer, which is 3.76. This is the answer of multiplying, and divide it by the number that I didn't use. So I'm going to divide it by 6. Divide it by 6, like this. This way, I will get the cost of 12x. So 23.76 divide 6, and the answer is $3.96. $3.96. So the final answer is 3.96, and this is the cost of 12 eggs. Same idea with 15 eggs. I just take 15, put it instead of the 12, multiply it by 1.98, and then divide the answer by 6. This method is called the cross multiplying or the X method. In this method, we usually use it with direct proportion and with proportions that increase and decrease together. And this is how you answer a question like this. Now, let's move on to the next question. Question three has the same idea. You have text messages, so 80 text messages, and here we have this is the cost of 80 text messages. Here we have 150 text messages, and this is the cost of 150 text messages. Now the question is, who has the better deal? Basically, you're supposed to find how much money does one text message cost, and by that you will know which one has a better deal. Now, to find the cost of one text message, what do you do? Very good. You divide it, you divide the cost by the text messages. So first we have 2.80 divide 80 text messages. So each text message will cost 0.035. So I'm going to write it here, 0.035. This is the cost of one text message for the first bill, which is orange. And the second one, I will divide £5 10 by 150. £5 10 by 150. So 5.1 divide 150. And the answer is 0.034, like this. Now, which one is the cheapest here? Very good. It's this one, the second one. This means that the cheapest is the better deal. And this is how you answer a question like this. Now, let's move on to the next questions. Here in question 4, a laboratory takes these readings for variables of x and y in one experiment. Plot the points for x and y. So basically, you come to the grid and plot these points on the graph using a grid, okay? So I'll do it very fast here. Let's cover the space here. Let's say we have a grid like this. This is the x-axis and this is the y-axis. Now here we have on the x 0.6 and on the y 5.4. Let's say that we have the numbers like this, 0, 1. Now you notice that the x starts with 0.6 and ends with 2.4. So you can make it till 5, for example. 1, 2, 3, 4, 5, for example. You don't need more than that. And the y-axis starts with 5 and ends with 21. So basically you just need to reach that 25 or 30. So I'm gonna go by fives. So that's a 5. That's 10, like this. 15. I'm gonna go by 5. And I'm gonna give more space here. 10, 15, 20, 25, and 30. So 30, 25, for example, and 20. This is not an accurate grid, I know, but I'm just showing you the idea and how to answer a question like this. Now, if you have an accurate grid, you'll do the accurate points on the grid, okay? So for x and y, here, this is 0.6. So on the x, 0.6, which is here. This is 0.5. So this one is 0.6. And then we go up till we reach 5.4, which is over here. Something like this, okay? Now, the second point, we have 1.7 and 15.3. 1.7x, which is over here, and 15.3, which is over here. And the last one, we have 2.4 on x, so 2.5 is here, and this is 2.4. And then we have 21.6 on the y, so 21.6 is over here. Something like this. These are not accurate because the grid itself is not that accurate, so you have to focus on or plotting accurate points on the grid, okay? Now, that's the first part of the question, plotting the points. Now, the second question says, does the graph show, let's put this here, Let me remove this so I can read the question. Yes. Now, does the graph show that the variables are in direct proportion or not? Now, I just have to match them to check if they are direct proportion or not. So to match them, I'm going to put a line like this. I will notice that it's a straight line and it's from the origin, which is a 0, 0 point. This means that the graph shows variables in direct proportion. Yes, they are direct proportion because they are a straight line that starts from the origin. Now, question C here, work out y divide x for each pair. So I'm going to divide y over x for each one of them. So let's start with the first one. So 5.4, 5.4 divide 0.6 and the answer is 9. So that's the first part here. Here we have 15.3, 15.3, sorry, divide 1.7 and same answer which is 9. And the last one 21.6, 21.6 divide 2.4 and the answer is 9. Now, dividing y over x gave me 9 every time. This means what? This means that the variables can be checked without plotting a graph. If I divide the y over the x and it gives me the same number all the time, this means that this is the constant of proportionality. The constant of proportionality, because this number is always constant, it's the same. This means that the variables are in direct proportion. This means when you write the equation here, it's going to be y equals a number times x, and this number is 9, and it's a constant number here, it's a 9, okay? How does I can't see the rest of the question, but it's okay. You understand the idea of direct proportion and how to find the graph and how to plot the points. At the same time, how to find out if it's direct proportion or not. Now, let's move on to the next question, okay? Next question here. Okay, now let's move on to the next question. Let's move this here. Let me remove this. Sorry. Okay. Same idea here. They will ask you to check if this is direct proportion or not by dividing the y over the x. So you divide the y over the x all the time. If they give you the same number, it means it is direct proportion. If the number is different, it means it's not direct proportion. Same idea here. We don't have to do it. Now, finding values or the values of variables, if we have a direct proportion table like this, how do we find the missing values? Let's take a look at this example here. Basically, we use the same method that we used in the first question with the x. We use the x method between four variables or four numbers. One of them is missing. We can use the x method like this. So we multiply the ones connected with a line and then divide them by the ones we didn't use. So first, let's start with this one. We multiply 25 by 12. So 12 times 25, we got 300. And then we divide it by 8, which is the number that we didn't use. And the answer is 37.5. Now we write it here, 37.5. Same idea with the value of b. I'm going to do the same idea, which is the x method like this. Multiply the ones connected with a line. So 12 times 50. And then I take the answer and divide it by 37.5. And I get 16. So B will be 16. Very good. Same idea. I'll go down and do the X method again, like this. Multiply 16 by 62. So 62.5 times 16. And then divide it by 50. And the answer is 20. So C is 20. Let's see here. Yes, so C equals 20. Let's write it here. C is 20. And then the last one here, same idea. I'm going to do an X method here. Multiply 62.5 by 20 times 20. And then divide it by 20. And the answer is 62.5. So, as I said, you have to focus on the steps. 62.5. Now, we're going to check again the steps if we have the right answers or not. Now, basically, multiply this by this. So 8 times 37.5. Okay. And then divide it by 25. I got 12. Good. So this one's good. Here we do multiply 12 by 50. 12 by 50. And then divide it by 37.5. I got 16. And then 16 times 62.5 equals, and then divided by 50, which is 20. And then if this one is 20, it's the same. Now, same idea with all of them, and this is how you answer a question regarding direct proportion. Okay, let's move on to the next question. As we said, with direct proportion, we use this method to solve the problems and find the rest of the questions or the rest of the answers. Same idea here. We're missing the x, y, and z. So same idea. I'm going to do the cross method here. As long as the question tells me it is direct proportion, it means I can use this method to find the missing numbers. I'm going to multiply 128 by 162 and then divide it by 140 to find x. Same idea here, x, and then same idea here to find the missing variables. Now let's move on to the next question. If we have the same ideas, we don't have to repeat them. Just make sure that you get the numbers right, okay? Now, that's it for this lesson. Let's move on to the next lesson. 7.2, solving problems using direct proportion. Solving problems using direct proportion. Let's take a look at some questions here. Here, write down the equation of each line on the right. Now, talking about equations and lines, we talked about this in Unit 10, and we talked about this in detailed answers. So we don't have to do it here. You can go check the video of Unit 10 and how to write the equation of a line, finding the y-intercept, finding the gradient, and then writing the equation of the line. So you have to focus on the right steps on how to do that, and you'll get it, okay? Uh, okay. Okay, 1 second. So let's take a look at some other questions here, checking if it's direct proportion or not. As we said, we divide the y and the x, divide the y and the x. If it gives you the same number, it means it is direct proportion. Means it's direct proportion. And when you divide and you get the same number, this number is called constant of proportionality. We call it constant of proportionality, and we use the letter K to describe it, okay? So here, let's take a look at some questions here. Uh, Write a formula linking each pair of quantities. The cost C in pence of sending T text messages at 5 pence per text. This means that each text costs 5 pence, and the cost is multiplying the 5 pence by the T, which is the text message. So this means, how do you write the formula? You write it like this: C equals 5T, like this. Same idea with all of them. You just write a formula like this using the K, and the K here is 5, which is the constant of proportionality. Now, the cost C in dollars of X plants at $4 per plant. So each plant is $4. It means to write this equation, we're going to write it like this. C, the cost equals, each plant is $4, and each plant is X. So C equals 4X. Question C here. Yearly earnings E in pounds of a footballer who earns X pounds per week. Now this is different because he earns X pounds per week, and they need it in a year. This means we write it like this: E equals How many weeks do we have in a year? Very good. We have 52 weeks. It means we're going to write it like this: 52 multiplied by X. It means how much money he's taking per week multiplied by 52 weeks will give me the yearly earnings. And D here, the number of miles, M, traveled in 2.5 hours at a speed of X miles per hour. So this means that the number of miles, which is M, equals 2.5 hours at a speed of X miles per hour. So the speed is X miles per hour. We just multiply it by 2.5. Number of miles traveled in 2.5 hours because speed equals this. Yes, this is the number of miles. It's not traveled in 2.5 hours at a speed of X miles per hour. So it's going to be 2.5, sorry, X, 2.5 X. And then here the cost, C in dollars of N biscuits, sorry, the cost which is C equals in dollars of N biscuits at 35 cents each. So each biscuit is 35 cent. This means we write it like this, 35 multiplied by N. And that's the idea of writing a formula connecting two proportions or two values in direct proportion. Now let's move on to the next question. Okay. This question is very important, checking if these equations or formulas are direct proportion. Now, we need to understand the meaning of direct proportion and how to check if it's direct or not. We talked about two rules in direct proportion. First rule is what? First rule says that they must start from the origin, which is the 0, 0 point. This means that if one of the values is 0, the other one should be 0. That's the idea of starting from the origin point. Now, this is the first rule. Second rule is having a straight line. And having a straight line means that both of them increases together. So this means that if one of the values increase, the other one should increase with it. Now, to check for this, so let's write it like this: increase and decrease together. So these are the two rules of direct proportion. So first, let's check for the first rule. If the first rule is good, it means I can check for the second rule. But if the first rule is not good, it means it's not direct proportion. So let's take a look at the first one here. P equals 5s. How do we check for the first rule? Basically, we just come to the s. We come to the s. And we put 0 instead of the s. We substitute it by 0. And then we find the value of p. If we put 0 here and we get 0 here, it means the first rule is good. So let's check that for 1 or a. So we have 5 multiplied by 0. Let's put it here. Let's put it on top, yes. So basically p equals 5 multiplied by 0. So this means what equals 0? Because 5 times 0 is 0. So when s is 0, p is 0 too. This means that the first rule is good. Now, to check the second rule, we just put values like 1 here and check p. And then we put 2 and check p. If it's increasing with us, it means it is direct proportion. So basically, let's put 1 here. If we put 1 instead of this, 5 times 1 equals 5. Now we put 2. 5 times 2 equals 10. 5 times 3 equals 15. So basically, every time S increases, P increases with it. It means the second rule is good too. This means that A is direct proportion. And that's the idea of checking for direct proportion. First, you check the 0, and then you check the increasing and decreasing together. Now, let's take a look at C here. Let's check if it's direct proportion or not. I'm going to do A and B, and you'll do the rest. For C, or question B, same idea. I'm going to put 0 instead of the H, and then check the C. If it gives me a 0, it means it's good, and I'm going to check the second rule. So let's do it together. So C will equal 5 multiplied by the 0, and then plus 40. So this means that the C will equal 5 times 0 is going to be 0 plus 40. So this means that C will equal 40. As you can see, when the C is 0, when the H is 0, the C came as 40. This means that the first rule didn't apply. This means that this formula here is not direct proportion. So basically, when one of them is 0, the other one should be a 0 to say that they are direct proportion. And this is how you answer a question like this. Same idea for C and D. You can do it by your own and check if it's direct proportion or not. Now, let's move on to the next question. Yeah, sorry. Okay. Now, let's talk about finding values in data proportion. We have question 7 here. And writing a formula to linking data proportion. Basically, the video won't, we still have 7 minutes. I think we have to stop the video. Yes. Yes. Okay. Okay, that's it for this video. I hope you understood the ideas. Thank you very much for watching. See you next time.